Hi, this is Dr. Morton. I'm going to do a brief video to show you how to put the additional parts on your printed circuit board. So when you pick up your Viva board kit, you should have a sack with some parts in it that are through-hole parts, and then you should have a board like this that has all the surface mount parts on it. Once you get everything mounted, it should look like this. And let me just go through and explain how these all work. So first of all, there's a group of headers. There's two big 2-row 10-pin headers that bring out all the pins on the chip. Then these are female headers. They need to have the little pins pushed through the holes and soldered on the back side. Then there's a 6-pin header, there's a 5-pin header here, and female header, a 6-pin right angle male header, and a 6-pin female header here. There's also two 3-pin male headers complete with little shorting blocks in your kit, and there's one here and there's one there, and again there's shorting blocks. This one determines the voltage to drive your computer, and the shorting block shorts to the center pin, either the 5 volts output from the 5 volt regulator or the 3 volt output from the 3.3 volt regulator. And these regulators are fed by the input jack here that you also have to solder on that comes from your battery connector. There's a separate video that shows you how to solder on the battery connector, the 2.1 millimeter plug to the battery, to the 9 volt battery tab. The plug has some big holes in the back. You don't have to fill those up completely with solder. Just make sure you have a good secure connection and enough solder there to securely mount that so it doesn't wiggle around or get broken off when you try and plug it in. Next, there is there's a 2-pin header right here that can be connected to any one of your GPIO pins. And this, when it's low, the terminal block will bring out ground and the battery output voltage, which in this case, if you have a 9 volt battery plugged in, would be 9 volts. When it's low, it'll be off. When it's high, when you drive this with a 1 from any of the GPIO pins, then this transistor switch will turn on, and you'll have something very close to battery voltage here, minus a 1 junction drop, and it can support probably 150 milliamps without any trouble at all. The other 3-pin male header is over here, and this one selects. There's a push button that you also have to solder on. This push button can be used as a master clear or as a RC2 push button input. The jumper decides this shorting block goes on and shorts 2 of the pins together. In this position, it's set up as a push button input on RC2, and in the other position, it just works as a master clear. When you push it, it grounds that center pin and resets the processor, or if it's on the RC2, it grounds RC2. When you let it go, RC2 is pulled up with a 10K resistor, so it reads as a 1. So when the button's pushed, it's a 0, released, it's a 1. When the button's pushed on the master clear position, it resets the computer. When you release it, the computer operates properly. And then you have a switch. This switch determines whether you're on battery power through your regulators, or whether you're on the CP2102 UART TTL level to USB little converter. This one is all set up. You can put the pins so you can mount it this way, or you can make it so it mounts vertically. In my case, I mounted it like this. I don't know which way is best, but in any event, when it's mounted like this, or the other way, you can then plug this USB port into a laptop. It takes the micro USB plug here, and this will provide 5 volts and 3.3 volts. And when the switch is in the down position, then if this is plugged into a computer, then you can jumper for 3.3 or 5 volts, and you'll run the processor on that voltage, and you don't have to have a battery connected. You can also run it on your programmer, which connects to this right angle pin. Just a couple of points. Make sure the right angle pin has the short portion into the board and the long portion sticking out to connect to the PicKit 3 programmer. Likewise, make sure these 3-pin male headers have the long pins sticking out of the board and the short pins into the board. This little push button, you can see here, it looks square, but it's not quite square. The pins are actually, it's rectangular, and it'll really only go in comfortably one way. And once you snap it in, it actually will stay there. It won't even fall off the board. And then you can easily solder it. This switch is a little bit more difficult. It has 4 pins that solder the case to ground, and then it has 6 pins because it's a double pole, double throw switch. The center pins bring the voltage up to this jumper, and in one position it's routing the voltage from your USB header, and in the other position it's routing it from your 2 regulators through your battery in. So that's the extra things you need to put on. 2 double row 10-pin headers, 1 5-pin header female, 1 6-pin header female, 1 6-pin right angle header male, 2 3-pin male headers with shorting blocks, 1 2-pin female header, and a terminal block to connect to your switch, your transistor switch, which you again have to drive with this input from any pin you want. You also have to put on the push button, the switch, and the jack input. And once you get all that done, your board will be complete and ready to be used. All right, well, thanks for paying attention to the video. There's also a video on how to solder your battery clip onto your plugged 2.1 millimeter plug to go into your input. And we'll also have soldering demos and whatnot, a workshop set up by HKN to help you guys get started. That's it.